Okay, what is the gravitational potential energy of a helium atom on the surface of the sun? Good. Now, this question asks for gravitational potential energy. So we need to find U. Okay, U. Helium atom on the surface. The position is on the surface. Okay, on the surface. So this means that the R is the radius of the sun. Okay, radius of the sun. Yeah, we can imagine like this. Just take this as the sun. Okay, sorry. Let me draw it out. Yeah, this is the sun. Okay, and the helium atom is over here. Okay, so we need to find okay, the distance to the center of this is the sun. Okay, this is the sun, and to the center of the sun, distance to the center of the sun is the radius of the sun. Okay, radius of the sun. So we need to find the potential energy at this position. Potential energy at this position. So what's the formula for potential energy? Okay, sorry, excuse me. Yeah, so the formula for potential energy is this. Gravitational potential energy. Okay, gravitational potential energy formula is U equal to negative GMM over R. So we need to use two masses. Okay, here we have to use two masses. The mass of the sun, the point mass, and also the test mass. Look at it. We need to use the point mass and also the test mass. And the R here is distance. Just like before, we learned about field gravitational field strength. The R here is we take radius of the planet plus altitude. But now it is on the surface. It is on the surface. It is on the surface, so just take the radius of the planet. Okay. All right. So let's look at this. Okay. So the R here is taking the radius of planet only because the H is 0. Okay. So negative GMM over R. That's the formula. So U equal to negative GMM over R. Where the R is just the radius of the sun. Okay, because the altitude is 0. Because on the surface, yeah, because this one is on the surface only, yeah, on the surface. Okay, so remember you must have a negative sign here, yeah, negative sign, because you are inside the gravitational pull of the sun. Okay, you are not free from the gravitational pull of the sun. Okay, let's substitute all the values. Yeah, so what's the value for G again? G, if you still remember, is called the gravitational constant, 6.67 exponent negative 11. Okay, and mass of the sun. Okay, okay, remember this mass is one of it is a point mass, another one of it is the test mass. Okay, right now the point mass is the sun. The sun is the point mass because the sun he is a provider of the gravitational field. Helium atom is the test mass. Okay, helium atom is the test mass. So this is the big M, and this is the big M, and this is the small m. Okay, so let's write it the value. So mass of the sun is this one lah. Okay, mass of the sun. So just write it 2 exponent 30. And then mass of the helium atom is 6.67. And no, 6.6 exponent negative 27. Okay. So divided by what's the R? Just take the radius of the sun. Radius of the sun is 7 exponent 8. Okay, 7 exponent 8. 7 exponent 8. Look at here. Here there is no square. R does not have square. So for scalar quantity, potential energy is actually a scalar quantity. if scalar quantity, the R here no square. Yeah, not like before we learned about the field strength. Okay, like gravitational field strength. You look at here, gravitational field strength. We have square. You see that? We have square. Yeah, we have square. For vector, if vector we have square. Yeah, if vector, the R there got square. Even the force also. You see, the force is also a vector. Okay, if vector, the R there got square. But if scalar quantity, like this one, scalar quantity like U, the R no square. You see that? The R no square. Remember that, yeah? So, okay, let's calculate the value, yeah? Let's calculate the value and see what's the answer. I got the answer already, yeah? The answer is negative. Remember, potential energy has a negative sign. The answer is 1.26. 1.26 exponent negative 15. Negative 15. So this unit is joule because it's energy. So is the answer correct? Let's look at the answer, yeah? Yes, it's correct, yeah? Almost, yeah? Negative 1.25 exponent negative 15 joule. Okay, yeah, almost correct. So, okay, that's the answer. Okay, so let's look at the following questions. Okay.